Can you hear this? So this is not it's not this microphone. I just turned on the microphone that's on the camera, that's built into the camera. I'll figure this out later, as long as you can hear it, even though it's not up to my personal standards of audio quality. Let's just move along. So, okay, thank you for joining the second that has gone perfectly so far, Packet Bomb live stream experience. I've got my coffee in my networking with Fish mug. I met her at Shark Fest a few years ago, I think. She came to the Shark Fest and attended my session and gave me a mug, and I use it almost every day. There's no bourbon in here. So, where are we from? I moved this earlier on a Friday. Hey, Pinkesh, how's it going, buddy? Are people from Europe? Is this, able to join? I hope it's after work and, maybe you're sipping a beer or something. Where's my chat window? I guess I can just look at it from Austria. Very cool. There's lots of clipping and crackling. Oh, God. I really wish I knew why the other mic isn't working. It's enabled in Windows. I checked. It's selected as input. And I see the meter moving in Windows, but in OBS, the meter's not moving. It is enabled. It's not muted. I turned off Discord. Okay, some crackling. You know what? Lesson learned. I honestly didn't check that my audio was working before I started. That's shame on me. Shame on me. I should have done that. So, input for your mic. Yeah, I mean, it's, you know what? It worked perfectly last week. I did not change anything that I know. What changed? No, nothing changed. Well, sir, the application's not working anymore. Something must have changed. All right, so anyway, got my coffee. Last week we had, so if you are watching this in the future, the replay, sorry about all that. Today we're talking about Call of Duty and it not working. I imagine there's going to be a bunch of children who might find this video in the future. Look in the description, there'll be a link to go straight to the packets, okay? But for all of us, we're here in the moment. We can't skip forward, as much as I wish I could go back and redo all that. So, all right, I got my coffee. I hope you guys that are across the pond have had a great work week and maybe sipping a beer, ready to talk about some packets. It's, 9:42 in San Francisco. I got my roll out of bed, threw on a Shark Fest shirt. I got a stack of them. My kid is listening to me on her iPad behind me. I'm right here, but she's watching it on her iPad. Maybe she'll learn some stuff about packets. So, let's move on. Here's my website. Networking with Fish. You should check her out. She gave me this mug. She is a networking person. She talks a lot about troubleshooting. Good stuff. I highly recommend it. So, update on the PCs we talked about last week. I showed you guys last week my setup. Let me find it. Let me bring it up real quick, the picture that I showed you guys. This. Submitted this. Okay. So this, let me, this is my setup, my new PC that I built. This desk is gone. I have a new desk. I haven't taken a new picture. We talked about this last week. Don't look down at the bottom, the cable management. There are reasons for that. So, update. The built-in CPU cooler that comes with the Ryzen AMD, processor. It's like 80 millimeters or something. My case fans are like 140, and there's 3 of them are 140, and 1 of them is 120. And I could hear it spinning up and spinning down all the time. It was just too much. Let me bring up the chat so I don't miss everything you're saying. My daughter's in the chat. Cool. So I got one of these guys only for the quiet aspect, right? Not because it has an LCD screen and you pay a premium for that. That is definitely not the reason. But I did add this. I made this little thing. I'm teaching myself DaVinci Resolve, and I made this little neon sort of animated GIF to put on it. That's fun, right? Cool. So let me check my list. That's not it. Okay, so hope everyone's doing okay. We've been through a lot so far this year. There's a lot going on. I hope everyone's safe and healthy, and prayers for everyone's safety and change and everything that needs to happen. It's a rough time right now, so I hope you're all doing well. So we're going to talk about another application problem. Last week we talked about two vendors arguing with each other because an application wasn't working, and then when they couldn't pin it on one another, they went to the network, and then the network dude, Fidel, who sent me the case study, was able to demonstrate in the packets, actually no, it's this guy's fault. And so that's an application problem. You're looking for something that is broken and trying to understand why it's broken. This, right? So that's one type of problem. And we're going to look at another one of those today. And next, I think we will probably start to get into maybe performance, right? Because performance necessarily isn't broken. You're not looking for like a reset or something that causes an application to be broken. We're looking for why is this not performing as expected? And those can be a little more nuanced, a little more tricky. It gets more into TCP behavior. So I think in our next one, next week, we'll start to look at some performance issues. If I can figure out, since I have failed with the microphone, I now doubt my ability to do it, but I would love to be able to bring in guests and have some guests to talk about some things. My buddy Chris, who's on the networking subreddit, did an awesome analysis of a audio streaming issue. So, we can look at that one. Hopefully he'll come on and talk about it. If not, I guess I can do it, but he's a fantastic network analyst, and he's got some awesome case studies. Not Chris Greer. Chris, also my buddy, also very cool. Chris, I think it's like Margette or Margaret or Margette. I don't remember exactly, but Chris, he's been a part of Networking Field Day. He's taken part of some of those things. He has a website called Fragmentation Needed? No, that's probably not right. Chris No, I've completely failed. Oh. Completely failed once again. I'll find it. That's probably not his last name, Chris. Oh, he had an awesome case study about mold UDP. Fragmentation needed. That was right. This is one of the best case studies I've read. I think he does the whole thing by packet analysis and doesn't even use Wireshark. That's how good he is. So check this out. If I can get him on, I'd love to. We'll see. So, yes, performance things. Maybe we can look at some other tools. I'm happy to hear from you guys about content. Someone asked about TLS. Someone asked about SMB. I can put those on the list. We can look at some protocols. There's a new tool that's recently come out. I think it's called Brim, though that's the name of the company. Is the tool called Brim too? But it's a free tool. No, it's called Brim. This looks very cool, and I would recommend you check it out. I watched the demo last night. A couple of guys I used to work with are here at this company. This looks like a cool tool, so I need to use it a little bit, understand it a little bit better. But it looks really cool. So with that said, I did put the PCAPs. Someone last week asked if they could download the PCAPs and follow along. So I hope in the description. Wait, is it? Yes, in the description you can download the PCAP that we're going to look at. Okay, and follow along if you want. So, with that said, now that we're 20 minutes in, so Laura Chappell did a webinar about Brim. Great, yes. So hopefully that's online. Like I said, I haven't used it yet, but it looks really cool. Okay, so all right. So today's problem, I hang out sometimes in the Wireshark subreddit, and there's a lot of kids coming in asking about IPs and Xbox and how do I pull IPs from the lobby? How do I, and I don't know. I assume they want to do something stupid, or I don't know. But this one, the fact that he had the words capture analysis, I was like, oh, okay. And I started reading, and I was like, you know what? I'm going to try to help this kid because he's clearly putting in the effort to understand a problem that he's having in his home network. And honestly, when people come to me with like home network problems, it's like, for one, most of my experience is more in an enterprise environment. Not that matters necessarily, but just, home networks are like, you never know what you're going to get. And I didn't have a lot of confidence that I would be able to really find anything. Half the time you look at it and go, yeah, I think maybe you've got packet loss somewhere. Maybe your internet connection is not any good. It can be tough to pin things down when you have very limited visibility into what's going on. So I say kid, I don't really know. I'm making assumptions. I don't mean to be disparaging. He has a router that he's able to take a PCAP on, and that's where he took it. So he took the PCAP on the router, not on his PC, because, apparently if you try to run packet capture software while you're running some of these games like Call of Duty, it will crash. It's like an anti-cheating mechanism, so I have learned. So he took a PCAP. He says that the problem, he gets disconnected. I said, you know what, let me see if I can help this kid. So, and I talked about this last week, but ideally, before you start looking at a problem, looking at data, make an effort to capture data, you need to understand it as best as you possibly can. Ask a lot of questions, drill down, get specific, because Wireshark is a specific tool, right? It's a precision tool, a scalpel, whatever you want to call it. You're looking at individual packets. So if you can, the easier you can, whatever ways you can to narrow down a problem, it's going to save you work in the long run. So spend as much time as you can up front, asking questions, drilling down, narrowing down, so that when you're ready to look at data, ideally, you've already got a head start. So I asked him questions. Do you have any other application issues outside of this game? Do you get problems with other games? What about websites? They're not loading. Are they slow? Does it happen every single time or only sometimes? Does it happen like at the same point every time or different points? If you start the game at time 0, does it happen every time at 20 seconds, 5 minutes, whatever? Is it consistent? And then can you send me the data? So we answer these. I don't believe him in some of these necessarily, but I don't have any other applications, but for some reason I can't connect to Google related websites for a few minutes after I start up. Okay, that's oddly specific but weird. Okay, file that one away. He's definitely got some other problems. I don't have connection issues with any other game. Websites are fast. It happens every time I play. But the time it happens varies, right? So he included the PCAP on Mega, which I think I had to create an account to download, so I put it up on Dropbox for you guys. I didn't anonymize or anything. I mean, he put it up here for everyone to see. So that's it. All right, so Wireshark. Let's make it. Is that too much? That font gets really weird. It's fine. All right, let's put this align center. So this is, last week we talked about configuration, how to set up Wireshark from scratch. I haven't come close to setting all the things I normally have in my default profile that I have built over the years. I think if you do this all the time, it's good to have, you know, a default profile for you and profiles for different kinds of issues and troubleshooting. You know, something focused on IP, something focused on TCP, something focused on HTTP. I mean, it depends on, you know, the kinds of things you look at. For me, I don't do this that much. So I make changes as I need to make them, and then that's what I do. So I've made the changes that I need to make last week, and this is where we left it, right? Okay, so he sent me this PCAP. He's got some IP data in the thing that will be good, that we will reference. Just to get an idea of what we're looking at, you know, this is only about a minute, 59 seconds. We've got almost 9,000 packets. Okay. And then I want to see, okay, well, like, I'm assuming he has an unfiltered capture of all the traffic that is hitting his router, right? If something doesn't go to his router, we're not going to see it. So potentially, we're kind of have a pretty big blind spot about what's going on in his network if we're able to figure this out. So looking at conversations, at just the IP layer, we've got 170 different IP conversations, IP pairs. All right, there's a good bit of IPv6 going on his network, and we've got 116 TCP connections and 200 UDP streams. Okay, so if we look at his post, his IP is 0.54.1's his router. And he's got a couple of IPs that he thinks are related to Call of Duty, which Blizzard, I guess, is the company that makes it. Demonware is another company involved. I mean, I've played a little bit of Call of Duty, but I don't really know that much. So why don't we just filter on his IP as a place to start, see what's happening. So IP adder equals 192.168.0.54. Okay, and let's just kind of see what's happening. He makes the connection right off here at the beginning to a 37 address. Now, most of the time, I don't want to resolve network names in IP. But for now, I'm going to turn it on because it might help me, instead of having to go look up all these IPs to see what they might be, maybe some of them will resolve, and it'll be convenient. So name, resolution, network address. Did I just turn that on? Because nothing changed. I did. Okay, well, nothing changed. Fritzbox. I thought these had changed before, but we can look it up, right? If we go to IP and destination, right click, copy value, and do I have a thing open already? I guess I don't. IP lookup. That's nice. Okay. This is Blizzard, so yes. And maybe this is the one he actually even told us about. Oops. I'm still here, right? Yeah. Things seem to be slow. 37 to 5410. Yeah, so that's what he thinks is an authentication server. So maybe he's right. Good for him. Okay, so clearly we're talking to it. We're talking to his router. Fritz.box is the 01 address, his router. Just scrolling to see what's happening here, right? It's talking to NVIDIA. We are talking to battle.net. That one does sound familiar. I think that is some sort of game server for Call of Duty. Right? Again, everything seems to be okay. One thing I did well, we'll come back to it. I thought I'd noticed, if this is his local router, right? He's on a PC connected to it. There is some traffic between his PC and the router. And I thought I saw like a 40 millisecond round trip time between the two, which seemed not great. But all right, login queue. So this is maybe connecting to a game server or the lobby thing where you get connected to other players. More daemonware IP addresses, but it's doing its thing. I'm not gonna single one-off dupacks or something. I'm not gonna really spend a lot of time on those. But I'm just scrolling to see what it looks like. What is it doing? We do have a ping request timeout. This is to Akamai from his PC. Don't know what that's about, but I think the TTL is 1, so that's not going to go anywhere. Don't know. Is that a problem? I don't know. But again, when you're looking at this, or you're looking through the data, you're not, you're just looking for things. Our brains are pattern recognition engines. That's what they do. The more you do this, the more your brain is wired to recognize patterns in this data. So when people bring up Wireshark and they're not familiar with it, it's just all overwhelming because their brain hasn't been wired to see patterns through experience and effort. So it just takes time. And as we're going to see in this, you also need some networking knowledge. Probably traceroute. Yeah, that's it. That's a good point. Very well could be. All right, so we're going to start going a little faster. Still talking to a lobby, daemonware. Don't really see any problems jumping out at me. Okay, now we're hitting UDP traffic to a bunch of different IPs. Again, I've never looked at Call of Duty traffic or anything like that. Maybe this is now talking to all his peers. Maybe this is the thing that the kiddies are always after. What are the IPs of that guy who was mean to me? Maybe that's what that is. But there you go. And now they're talking back to him. Maybe they're just checking in to say hi. And then, yeah, a lot of UDP 3074, and I'm pretty sure if I Google that, it's going to show up as this game traffic. We're going to go a little faster. Again, I'm just looking for things that pop out to me. Clearly, we're chattering back and forth. And now, a big stream of UDP data to one IP address, which we could look up, and is probably a game server. So we're sending our data. Maybe he's playing right now, Maybe he's shooting people. And we're getting towards the end, so we haven't seen any problems. So, I mean, potentially we could have just zoomed to the bottom and looked for a problem, but, you know, it's not a bad idea to get a lay of the land. All right, now we're back to talking to the lobby. Maybe his game's over, or maybe that's just how the application works. And we do start seeing retransmissions, which I believe he talked about. Again, the person clearly doesn't know that much about networking, but kudos for giving it a shot. And he did see that there were retransmissions, and his computer didn't seem to be acking. And that's what a retransmission is. It doesn't get an act, so it sends it again. So let's drill into this a little bit. And we clearly have some. This is TCP on, so this is TCP 3074, right, instead of UDP 3074. And we're going, all right, now that we kind of got a feel for the IPs, let's turn that back off. Now what I'm always curious about when I'm looking at something like this is where we are in the byte stream, right? Because we're sending data, the server's sending data, and then it's two ways, duplex, right? And so you're having to act what you're receiving, and you're having to receive acts from what you've been sent. So I like to get an idea of where we are in that little dance, and that's why I like to include sequence number as a column, next sequence number as a column, and ACK as a column. Now, so they don't take up too much space, we'll just call this SEQ. And this one we'll call NXT SEQ. And this one will be ACK. So, you don't have to add this. You can look down at the packet details. But for me, if I'm trying to follow a byte stream, right? TCP, its job is to transfer bytes. It doesn't care what those bytes are, what application they are. Its job is just to transfer bytes, make sure that they all get there. And that's what the sequence numbers are for. This marks where you are in the byte stream and what has been acknowledged. So we are, let's come up to like right here. This is the server sending to us 98 bytes of data, TCP data. Right, so you take the current sequence number, you add the TCP link to it, you get what the next sequence number is expected to be. If you come to the next packet from that IP, it should match. So this column should match this column in order. The acknowledgement number says, okay, well, I've received all the data of 168994 up to and including 994, and the next sequence number I expect is 8995, which is this one. So that means it's acking this immediately, right? And here's what I was talking about, that round trip time, right? So this was received, this went out the router interface to the local PC. 40 milliseconds later, it got acknowledged. That's the LAN. I mean, it's not a problem, it just doesn't sound very good to me. Right, so that data is all acknowledged. He sends another packet with the next sequence number of 0245. We acknowledge it right here. So these match. And he sends, he's acknowledging data. 32278. He's acknowledging, I think, yeah, this packet up. No, not that packet. One of these other packets. This one. He's acknowledging this packet. It has data in it. So this is the last time we sent data to the server, right? That's 1,202 bytes. And so he is it's no data. He's just acknowledging that packet up there. Then he sends 322 bytes of data. No acknowledgement, which, you know, with TCP, sometimes we don't ACK every packet, right? We might ACK every other packet. How that behaves exactly depends on the TCP stack, but I'm not going to get too upset because I don't immediately get an ACK from a single packet. However, 375 milliseconds go by and we don't see anything, and we see the same packet, the same TCP sequence numbers. So Wireshark says, hey, we already saw that one. There was no acknowledgement. That's a retransmission. And we can verify that it's not the same packet as a duplicate by looking in the IP header at the IP ID 37262 37263. So that's the next packet in order, right? So the server sent data. For every bit of data it sends, it sets a timer. And if that timer expires before it receives an acknowledgement, that's a transmission timeout, and it will retransmit it, RTO. So it waited 375 milliseconds. We have some other TCP stream in here mixed in. And actually, let's drill down this so we can see this a little better. So we're going to do conversation filter TCP. Right, so here's the data that was sent. 375 milliseconds later, it retransmits it. 760 milliseconds later, it sends it again. Then 1.5 second, 3 second, 6 seconds. So as an analyst, as a packet person, even without the markings of Wireshark, these numbers should trip something in your head, right? There's something about these numbers. And what is it? It's doubling every time, right? That behavior is TCP retransmission. For each time it has to retransmit, it doubles the timer. And you see that back off, and eventually it will time out completely. But that's the last thing we see on this connection in this. So let's just click on like this one, and let's go back to our previous filter of just the IP. So clearly we have the PC stops responding, right? Now our job is to figure out, is this all traffic, just this connection? We're trying to find a pattern of behavior. So if we come down, we see a packet being sent 5, almost 6 seconds after this transmission. If I set here, let's set the time to since beginning of capture, and we're going to say the last packet that was sent, we're going to mark that as a time reference. So now, instead of starting at 0 for this column, time since beginning of capture, everything that comes after it is using it as a reference point. So like 11.5 seconds after things seem to go wrong, there is a membership report to a multicast address, to a multicast MAC address. Now, I stood up multicast on a network probably 15 years ago. So at the time I knew a lot about multicast. Anyway, membership report, if I remember correctly, is a receiver. Multicast works in groups, is saying, hey, I care about this multicast group. And it reports that to the switch. So if the switch receives traffic for that multicast group, it knows which ports are members of that group, and it'll send the multicast traffic on that port. So it's just saying, these are the multicast groups I care about, Mr. Switch. Please send them to me. So that's fine. I don't think it necessarily has anything to do. We could go look probably and see if these are well-known multicast groups. We could go look that up. So we have a couple of those. More retransmissions. We have our router trying to connect to us on port 80. I don't really know what that's about. We don't answer. We don't even send a reset. We just ignore it. Generally, if someone tries to initiate a TCP connection to a port you're not listening on, you don't have a server running on that port, the stack will send a reset back saying no one home. It doesn't happen. It retransmits a couple of times. We get another multicast, and we see some data still trying to be sent to our IP. No responses. So, clearly, other than this multicast thing, we stopped talking. So I'm going to go back to the last time we sent a packet on a conversation, and I want to see what else is happening, right? Because this is a wide open capture on the router, and we're going to clear it. Here's our packet. So we have some home plug AV protocol, right? Again, home networks, you get all kinds of junk. All your little internet of things talking to each other and media servers, and we have UDP traffic to something else on the network. Some other, whatever this .21 is, we could probably go look and see, but right now I'm not going to chase that down. Here was one of the packets sent to our PC. Here's another one, but again, not much else. And then we get here, and this is interesting. Who has 192.168.0.1 tell 192.168.0.54? That's an ARP. And that is our PC saying, hey, I know my default route, right? 0.1 is a default route. I have the IP. I need the MAC address. And it replies, hey, here's my MAC address. So if you want to talk to me, this is where you can find me. I assume that the ARP table, do I have timed out, and it had to refresh it. This is Windows Terminal, which is not bad. ARP -A tells you the mapping on my PC, mapping the layer 3 address to the layer 2 address. Remember, you have to understand the networking stack, the model, OSI, if you will. The layer 2 address maps to a layer 3 address. So for me, my .1 address is located at this physical address. So this will time out eventually, and we will have to ask for it again, and it will tell me, right? So that's what's happening, and it replies. Now, when I saw this, I go, okay, this one is definitely a flag for me. I don't know if it's something. I scrutinized it. Okay. You know, we're asking for the IP. I made sure that the reply was the correct MAC address. I couldn't find a problem with this ARP itself. But then I got to wondering, okay, I didn't see that in my previous filter because I was filtering at layer 3 on the IP address. Well, this PC is talking at other layers. I need to know what else it's doing. So I'm going to filter then just on its MAC address to get any traffic that it's sending. And this is its MAC address, so we will apply as a filter. And okay, so this again is the TCP conversation we care about that was happening. Da 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 da, it's going fine. Then we ARP, and after the ARP, the retransmission start. Big flag. But I couldn't find a problem with this ARP. I'm like, well, maybe it didn't get lost, surely, but I guess it could have, but wouldn't it have just ARPed again? I don't know, but something's weird about this. So let's go back through. Now that we're seeing more than just layer 3 traffic, IPv4 traffic, that's what we were filtering on. Let's go back and have a look again. So again, we see the membership reports, but now we are seeing some IPv6 from our MAC address, and these are DNS queries for Call of Duty stuff, right? Battle.net. Now, I'm not an expert. I'm not an expert on this, but I'm wondering if Windows, if it fails to get a response with IPv4 DNS, it will then try IPv6. So do we have an IPv4 problem? IPv6 doesn't require ARP. It has a different protocol. So again, looking for this, I don't see any traffic being sent. It's not multicast and not IPv6 from this PC after it ARPed for its default route. And again, we're blind because we're capturing the router and not the PC. So I said, all right, what if we just look, is this the only guy having a problem? I don't know. I got curious about what was happening with ARP traffic. And so I did ARP. And, I'm seeing ARP announcements, I'm seeing ARP requests, and wait, what? Gratuitous ARP for, address that we do care about, duplicate use. Now this is Wireshark telling you something. This isn't in the packet. So what is this? So we have a gratuitous ARP, meaning it's a reply that no one asked for. It's like, before you can even ask someone how they're doing, they just launch into a 10-minute tirade of all their ailments and, things they're upset about. No one asked for this, but someone's sent a reply saying, "Hey, this is my MAC address." This was sent by a TP-Link device, but it was sent directly to the router. It's not a broadcast, but it is saying, "Hey, this is my MAC, this is my IP, this is your MAC, and this is what you're saying your IP is." So you Google for TP-Link, that's a network device, switches, wireless things. His router is a Fritzbox. Oh well, I don't get me wrong. I could not. I did not dive into the details of his network topology, which I should have. Honestly, the more I know about his setup, because clearly it's a little bit complicated. He's got lots of devices. He's got a router, which he calls the Fritzbox, and he's also got a TP-Link device saying, "I have that IP." So what I believe this is, because it's not a gratuitous ARP as a broadcast, like something comes up, on the network and tells everyone, "Hey, you can find me here at this is my IP and this is my MAC." Or if you're moving an IP address, a layer 3 address, to a different layer 2 address, like if you move VMs or something, failover happens right between redundant hosts and you have the same IP, well, now the MAC address has changed. So you need to tell everyone, or you need to tell the switch, "Hey, this is where you find this IP and this MAC now." All right, those are the kinds of things many times are broadcast. This was unicast, so I think this is the TP-Link saying, "Hey, excuse me, we seem to have a disagreement here, but this is my IP." And then, the router's like, no, this is my IP. So I went back and told him, it looks like you have a TP-Link device that is configured with the same IP address. I don't know what you're using it for, what it's there for, but you either need to change its configuration for it to stop acting as, you need to change its IP. You can't have two devices. So what I think happened is we don't have the data, is our PC ARPed for its default gateway, and this guy replied first. He beat the router and said, "Oh, here's a MAC address." So from that point on, we started sending the traffic to this TP-Link device and essentially black holing it. It's not going anywhere. Once he changed its IP, the problem went away. No more disconnects. He's killing people all day, and his weird issues not connecting to sites for a few minutes cleared up as well. You know what? I rarely use expert info stuff, but if you click on this button down here, oh man, if you click on this button here and just like glance through it, it's like, ta-da! But what would I have learned? So, there you go. Add it as a filter. ARP.duplicate-address-detected. That's the coloring rule here. I'm pretty sure. If we, let's go back. Though mine's not showing up as, I'm not sure why it's. I probably disabled. In the last video, I disabled a bunch of coloring rules. No, it's not. I see. The packet itself is not colored. You could, though, if you wanted to. So this is the expert info, right? Expert info is just Wireshark trying to be helpful, looking at the packets, making educated guesses. What would I do? Right click on this, right click on that. No. That's it. So if you say copy as a filter, and you went to coloring rules, if you wanted to add it, you could say the filter is that, and the color is, foreground blue, background red. That'd be terrible. Why is it black? Oh, I didn't move it. There we go. That looks terrible. And enable it. I think that'll work. Oof. There you go. Yeah. So that's how you could do that. If you wanted to call those out. I can't. My eyes are burning. Right. Okay, so you know what? I didn't expect that I would be able to really figure much out for this kid. I had someone else private message me, hey, can you help me with Wireshark? And he hasn't gotten back to me. Because like I said, tons of people post, and I think they automatically get removed from the Wireshark subreddit at this point. If people just ask how to pull IPs. So he went and did that, fixed the problem, hooray, hooray. That was fun. So, next week, I will fix the audio problems. Lesson learned. Shame on me. Again, let me know what you guys want to see. Shoot me something on Twitter. It's Packet Bomb on Twitter. If you want, I put a link for this Discord server that I created that I haven't used, but I also not have put the link anywhere, so no one could obviously join it. So I work from home, right? In today's environment, I'm sitting here in front of my computer doing work. I check in multiple times a day on Discord. So if you want to talk packets, I'm usually there. But email works, Twitter works. Yeah. Let's see. Dan, glad. I wish you guys could see this. So my buddy Dan, who is a Bay local, who is a packet guy, also has chickens. I told the story last time, but we met, had lunch. He gave me a dozen beautiful organic pasture-raised eggs, which I ate all of them. We raised the chickens. He can't sell the eggs right now to restaurants as he does. Anyway, he's watching the live stream, and there's a chicken in the way. I've seen lots of like videos of puppies or cats. Really, that's the first one I've seen picture of someone of their chicken getting in the way. Anyway, so I hope you guys enjoyed that. I hope you have a great weekend. Stay safe. Let me know what you want to see. It's fun to do this. I like trying to help people and solve problems. I like excuse to set up elaborate, expensive AV equipment. So you're giving me the reason. I'm working on learning DaVinci Resolve because it's free, and I hope to actually put out some quality produced videos as well. We'll see how that goes. All right, guys, I'm gonna end the stream, but I'll leave the chat open and I'll address any issues. I'm sure I missed some issues in the chat. So see you next time.